Hello everyone, my name is Roman, and in this video I'm gonna tell you about our program A Simple Three-Way. To find this program you should visit our site simplepoker.com, then go to the Products section, a Simple Three-Way subsection, and here you can download the program and purchase it, and also read basic info about it. So Simple Three-Way is a solver for the Postflop three-way spots, which does the calculations without abstractions. You can purchase it for $249 USD for 1 year for one PC. But if you need to switch the PC, if you want to transfer this program from one PC to another, you are free to do so. And if you tried the beta version of the program before, you will still have to download the full program right here on the website, because the beta will not update to the full version even if you purchase the license. Okay, now let's get to the program itself. This is the interface, pretty much standard interface for all of our products. 3 menus on top, File, Cloud and Standalone, and let's go through them. Okay, here we can open a calculated solution, we can save our solution. We can update the program. By default, you will get updates as long as they come. And the last two options here is about the program and exit. Next we have Cloud, and here you can find some free calculated flops. You can download any of those flops anytime you want and check out how these three-way spots work on the flop and turn. But we will get to this a little bit later. And you can actually purchase a pack of solutions, which you can find right here. Go to Solutions, Simple Three-Way, and here it is, one pack for spin and go flops, where we have 74 solved flops for three-way spots in spin and go with effective stack of 18 BBs and a pot of 6 BBs. But if you want to purchase a pack, you need to first register on our website. Or if you did this before using some of our other products, then you just have to log in. You purchase the pack on the website, you log in here in the program, and you will see those spots right here. And finally, standalone, we have two menus, License and Settings. In License menu, you can enter the license key, so if you have a key, you just click this button, enter license key, and copy-paste it. Also, you can deactivate the license for this PC and activate it on other computer. Now, Settings menu. In this menu, we can set up the calculation options. We have 5 algorithms for the flop calculations, 3 of which are vector algorithms. Well, they are quite precise, they are not using abstractions, and they can estimate the exploitability of the solution. And we also have 2 Monte Carlo algorithms, which, as you have probably guessed, work on Monte Carlo simulations. But let's first go through the difference between 3 vector algorithms. A1 is the most RAM efficient algorithm. So if you want to do the calculations using the least amount of RAM, go with the A1. By the default, it requires 2 times less RAM than A2 and A3. And that's basically all I wanted to say about A1. Now about A2 algorithm. This one is the most stable, the most consistent. It always converges, but it requires a lot of RAM. Well, at least more than A1. And finally, A3 is the fastest one, but sometimes it will not converge and give you bad Nash distance, meaning that the exploitability of the solution will be way too high. And now Monte Carlo algorithms. Well, basically ES-CFR is faster than CS-CFR, but sometimes with some really complicated trees, CS-CFR could be much more precise than ES-CFR, but those cases are quite seldom to occur. Oh, and also you can use compression for this A1 algorithm. So if you choose the maximum compression x4, this algorithm will use 8 times less RAM than A2 and A3. But of course, compression reduces calculation speed. Okay, for the flops, we recommend you to use this ES-CFR algorithm because it is quite precise and quite fast too. But for turns and rivers, we only have vector algorithms because they are more precise, and turn and river calculations are not so big and tough. Then we have an option to load next street info, which means that we can save the solution for the next street. If we calculate turn, for example, we also save the results for the river. But this option is not available for the Monte Carlo algorithms because they are not calculating turns precise enough. So yeah, no next street info for Monte Carlo algorithms. And we can also choose the level of abstraction for Monte Carlo algorithms. If we pick small, this is the fastest option with the smallest system requirements, but it will also give the least precise results. If we pick perfect, well, this one is very close to no abstraction calculations, very resource demanding, quite slow, but yeah, very precise. Then we have this little scroll bar which only works for the vector algorithms. And basically it determines the percentage of the calculations that will be done with the simplistic version of the algorithm. And if we pick 90%, then 90% will be done with the simplistic version of the algorithm and 10% with the most precise version of the algorithm. And why would we use these simplistic algorithms at all? The idea is that after 90% we get to some solution, so we use fast iterations to get to some solution, which is not quite precise. And then last 10% of the calculations, we use these very slow but very complete iterations to make this solution as precise as possible. And yeah, here we can pick the level of accuracy, which of course affects the time of the calculation. And yeah, for the Monte Carlo algorithms, the exploitability of the solution is not estimated. Well, it's basically impossible because it is a completely different approach. Okay, let's pick ES-CFR, low accuracy. Oh, and I forgot that you can pick the amount of threads the program will occupy. My CPU has 8 cores, which means 16 threads. So I usually pick 15 to leave one thread free. So I can browse and use other applications while a simple three-way is doing the calculations. Okay, on the top we will see the results of the solution. In the middle is the area where we basically input all the data about the situation that we want to solve. And in the very bottom we will see our game tree. Okay, first we need to pick the board structure. Let it be Ace, King, Queen, Rainbow. Just the flop for now. Then we need to pick the stacks for all 3 players. And since we are looking for the flop solution, we have to enter the flop stack sizes. Okay, let's assume we have 3 equal stacks of 80 BBs. And here you can either put the amount of big blinds that every player put in the flop pre-flop, or you can pick the sum of 3 bets and put it here in the dead money. It will not affect the calculations in any way. But okay, for now, let's say that everyone put 20 BBs in the pot before the flop. And as you see, main pot is now 60 BBs with the effective stack of 80 BBs. And if you want, you can choose different stacks for different players, and you also can choose which player has folded pre-flop. And in this case, the program will take into account the range of the guy who folded. Next, we have to choose sizings. Again, absolutely standard menu for our products. We can choose up to 3 sizings for every street. We can choose the maximum amount of bets for one street. We can add an open shoving option. We can add that every last action will always be all in. We can round bets to the certain number, and we can always go all in if the bet is larger than a certain percentage of the stack. Yeah, and after all, we can name this strategy and save it. And after you can find here your saved strategy. Okay, this is always calculated in GPV. We cannot account for the rake, and we can choose which player is out of position. So if, for example, player number 2 is out of position, then he's the first to act, then player 3, and then player 1. And now if we apply this situation, we get a game tree down here. By the way, if we want to edit something in this tree, we can do it right here. We right click on the node, we click add node, for example, if we want to add another sizing, and here it is. And if we don't like the sizing, we again can change it by using this edit node function. Let's make it 45. Alright, now we have our game tree, and now it is time to pick preflop range for every player. Well, basically it's a standard range editor. You can right click on a hand to deselect it. You can left click to select it. You can go like this to deselect all of them. And for example, if you want 100% of those combos, you just left click on all of them. Then you move the scroller to 50% or enter it manually right here. And now you select only 50% of those combos. And yeah, we can apply this range. We also have some standard ranges here you can choose from. But mostly you will probably have to build ranges on your own for every spot. And by the way, you can save any range that you've built. Again, you choose a name for it, and then you can find it in this drop-down list. Yeah, and from this moment you can calculate this flop. But for now, let's take a look at some free flops. We go to Cloud, Situations, and let's pick any of those. Yeah, doesn't matter, we pick one and click Download. Okay, here in the matrix on top, we see how we should play every spot, every node of the game tree. Yellow stands for check, green for bet, and as you can see, here we check all of our range. That's for player 1, player 2. Okay, here we see some mixes. We see some checks, some bets, and if we click on a certain hand on the right, we can see how exactly we should play with it, with different suits. We see all the frequencies, and if we click on a certain combo down here, we see the frequency of every action and the EV of this action. And let's assume that player 2 checks, player 3 bets, and yeah, we see the reaction of every player. And in the middle, as you can see, all the hands are separated by the strengths of the hand, by the type of the hand, and also we see how we should play with those different types of hands. Okay, now if we want to check out the turn, we click here, we pick the turn card. As we see, there's no solution for it right now, but we can download it for free again. And we do it, and here it is. I also want to point out one important thing. For every user, even for those who do not have the license, we offer a completely free river calculations on our servers. For this, you go to standalone settings, and on the river choose this remote option. Now all the river calculations for you will go through on our servers, and again it is absolutely free for everyone. So you have some free calculated situations, and you can calculate any river spot for free. Okay, now let's try to calculate this river spot on my computer to see how fast it will go. Let's run it. And as you see, it only takes about 5 seconds. Oh no, not really. I forgot that the first 90% go through the simplified algorithm, and the last 10% are going through the completer version of the algorithm. In the end, it takes well, about 20 seconds. Okay, we get our solution for the river with Nash distance of 0.017, which means the maximum exploitability of about 1.7 BB per 100 hands. Now I want to drive your attention to the flop calculations. For example, if we want to use the vector algorithms for the flop calculations, as I said before, yes, they are quite precise, but they are also resource intensive and time consuming. And if we pick the Monte Carlo algorithm, even if we choose the smallest amount of abstractions and the lowest accuracy, we in the end get the results that are quite precise, I would say, for the flop. So it allows us to get precise results for a small amount of time. Okay, here is our downloaded solution for the flop. And now I will run this program once more. So we have two windows. And let's go to the free solutions. Okay, Jack 44 is the one with Nash distance of 0.079. Let's download it again. But now we will calculate the flop on our own using the ES-CFR algorithm. This approach actually allows to calculate flops pretty quickly. As you see, we have already more than 10%, and this game tree is quite complicated, and it will eventually take, well, probably less than 30 seconds. And this is actually a unique approach. As far as we are concerned, no other solver uses this approach. And yeah, as I said before, Nash distance is non-available for the Monte Carlo algorithms. And now we can compare the solutions. Okay, visually, if we look at hand types or at the metrics, these two are very similar. And the solution on the left has been done with the vector algorithm, which is very precise, as I said. Okay, let's dig a little bit deeper. Yeah, here the solutions are also quite similar. Well, of course, there are some differences and we can spot them, but they are quite minor. And we can actually increase the precision of this Monte Carlo algorithm by choosing the medium amount of abstractions and middle accuracy. Of course, we will not get to the point of accuracy as with the vector algorithm. But I think you agree that this is quite nice to calculate a three-way spot on the flop in like 30 seconds or even less. Okay, this is all I wanted to say about this program. If you have any questions or maybe some suggestions on this product, please join our Discord channel. You can find the link in the description of this video. Thank you very much for your attention.